In the basic principles of real physics, we mentioned that mass is a neutral thing that possesses neither force nor any godlike ability and cannot be converted into energy. The only property that mass has is inertia. And the fact is that bodies of mass cannot exert an attractive force on each other. We will discuss later how the Earth's gravity comes about. If you take two iron balls, one large and one small, and let them roll around on a table, you will find that the smaller the ball, the more flexible it is, and the larger the ball, the more sluggish it is. This is a fundamental property of a body of mass, known in physics as inertia. So far, our knowledge of inertial forces has been limited to this rough concept. But that is not enough. We all know from everyday experience that the faster a car goes, the harder it is to stop. And the faster a rocket flies, for example, the more difficult it is to accelerate it further. This example shows that the magnitude of this inertial force increases with speed. If an object is accelerated with a constant driving force, its inertial force increases with increasing speed until it balances the driving force. At this point, the inertial force cancels out the driving force completely. Although the driving force continues to act on the object, the speed of the object cannot increase any further. In other words, the speed of an accelerated object is limited. To accelerate an object further, a force greater than the inertial force of the object itself is required. To decelerate an object, a force greater than the inertial force of the object is also required. This means that an external force that is not greater than the inertial force cannot change the state of motion of an object. This is the main property of the inertial force. In modern physics, there are various interpretations of inertia. For example, Newton's first law is also known as the law of inertia. However, Newton's law only applies in the case of linear motion without the influence of external forces, a condition that does not occur in reality. In fact, all common interpretations of inertia fail to recognize the essential point. In other words, nobody has really understood the nature of inertia, neither Newton, nor Einstein, nor Stephen Hawking. This is a fatal flaw in today's physics. In the next few videos, we will find out exactly how great the force of inertia is and what the maximum speed of an accelerated object can be. For a more detailed explanation, please click on the link below.